Good morning, students. Now, the last topic is this one. Now, let U1 U2 be an orthogonal basis for a subspace W of R power n for each y in W. The weights in the linear combination y is equal to C1 U1 plus so on CP UP are given by Cj is equal to y dot uj by uj dot uj, where j running from 1 to p, right? ఇది ఆల్రెడీ ఎక్స్ప్లెయిన్ చేసినాం కదా మనం ఆల్రెడీ. Right. Now, see the next one and the problem based on that one. Example problem is there. Now, one set is given to you. S is equal to what? U1, U2, U3. There are three vectors are there, right? Now, the set S is equal to U1, U2, 3 is and the example one, of course, that should know. Now, is an orthogonal basis for R cube. Express Y. What is Y? Y is given as 6 1 minus 8, right? Is a linear combination of the vectors of S. Linear combination of the vectors of S. Now what is u1 here? U1 is equal to given as 3 1 1 and u2 is equal to minus 1 2 1. Next u3 is equal to minus 1 by 2 minus 2 7 by 2, minus 1 by 2 minus 2 7 by 2. These are the three vectors. Now we have to write this vector y as a linear combination of these three vectors. Linear combination, do you know this one? No? What do you mean by linear combination? The vectors are multiplied by scalars and their sum. The sum of the product of the scalars and vectors is called linear combination. Now we have to express y as a linear combination the vectors of u1 u2 u3. Then y is equal to what? C1 into u1, C2 into u2, C3 into u3, where c's are scalars, right? This is a linear combination. We have to find c1 c2 c3, right, and so on. There are three scalars are there. Now we know that c1 is equal to what is c1? Y dot u1 by u1 dot u1, right, by using above theorem concept. And c2 is equal to what? Y dot u2 by u2 dot u2. And c3 is equal to what? Y dot u3 by u3 dot u3. Now to find c1 c2 c3 values, we need to find y dot u1 and u dot u1, u dot u2, u2 dot u2, u3 dot u3, right? First of all, I am finding u1 dot u1 is equal to, dot means inner product. Remember that it is an inner product. Now this can be written as u1 transpose u1, no? Right. Now what is u1? 3 1 1 transpose, right? This is 3 1 1, which is equal to 3 into 3 plus 1 into 1 plus 1 into 1, which is equal to 9 plus 1, which is 11. Therefore, u1 dot u1 is equal to 11. Next, we need to find u2 dot u2. That is u2 transpose u2. Right? What is u2? Minus 1 to 1. This is minus 1 to 1. Right? Now, multiplication. Minus 1 into minus 1 plus 2 into 2 plus 1 into 1, which is equal to 1 plus 4 plus 1, which is 5 plus 1, 6. Right? Now therefore u2 dot u2 is equal to 6. Next we need to find u3 dot u3, right? What is u3 transpose u3, which is equal to minus 1 by 2 minus 2 7 by 2 minus 1 by 2 minus 2 7 by 2. Product is equal to minus 1 by 2 into minus 1 by 2 plus minus 2 into minus 2 plus 7 by 2 into 7 by 2. This is 1 by 4 plus 4, 49 by 4. LCM is 4, 1 plus 16 plus 49, right? 50, 66 by 4, right? Which is nothing but on simplification 2 times, right? 33 by 2. Therefore, u3 dot u3 is equal to 33 by 2. Next we need to find y dot u1, y dot u2, y dot u3. Now see here, y dot u1 is equal to y transpose u1 as per definition. What is y? 6 1 minus 8 dot u1 is what? 3 1 1. Product is what? 6 into 3 plus 1 into 1 plus minus 8 into 1 is equal to 6 3s are 18 plus 1 minus 8. Now what we are getting here? 11. Therefore y dot u1 is equal to 11 we are getting. Next we need to find y dot u2, right? Y dot u2 is equal to y transpose u2 definition. Now what is y actually? 6 minus 6 1 8 minus 8. u2 is what is u2? Minus 1 2 1. Product is 6 into minus 1 plus 1 into 2 plus minus 8 into 1. On simplification, this is minus 6 plus 2 minus 8, right, which is minus 12. Therefore y dot u2 is equal to minus 12. Next one is y dot u3. How to find out? Y transpose u3. 6 1 minus 8. u3 is minus 1 by 2 2 minus 1 by 2 minus 2 7 by 2. Inner product is 6 into 1 plus 6 into minus 1 by 2 plus 1 into minus 2 plus minus 8 into 7 by 2, which is 6 into minus 1 by 2 is minus 3. 1 into minus 2 is minus 2. Next, minus 56 by 2. On LCM, what we are getting? 2 minus 6 minus 4 minus 56, that is again 66 by 2, that is with minus sign, no, that is minus 33. Therefore y dot u3 is equal to minus 33. Now therefore simply substitute those values in the linear combination. Therefore y is equal to, what is c1? c1 is this one. Oh sorry, we need to find c1, no, right? c1 is equal to y dot u1 by u1 dot u1. What is y dot u1? Y dot u1 is 11. 11 by u1 dot u1 is also 11, which is nothing but 1. Therefore c1 is equal to 1. Next, what is c2? Y dot u2 by u2 dot u2. What is y dot u2? Y dot u2, did we calculate y dot u2? Yes. Minus 12. Minus 12 by u2 dot u2 is how much? 6. This is equal to minus 2. Therefore c2 is equal to minus 2. What is c3? Y dot u3 by u3 dot u3. What is y dot u3? Minus 33. By u3 dot u3 is 33 by 2, which is nothing but 2, right? Therefore c3 is equal to 2. Therefore y is equal to, what is c1? 1 into u1 plus what is c2? Minus c2 minus 2 into u2 plus c3. What is c3? 2. 2 into u3. Therefore y is equal to u1 minus 2 u2 plus 2 u3. Now y is expressed as a linear combination in the elements of S, right? Now see, what is see this one? u3 dot u3 is minus 33, no, right? Minus 33 means you will get minus 2 here, right? Minus 2, this is minus. Okay, please cross check this one once again. Okay, right. And next one is important topic. This one is an orthogonal projection. See, orthogonal sets is over, and then next theorem based on that problem. Next one is orthogonal projection. See, orthogonal projection is nothing but simply you have to find another vector related to the given vector. See, y is a vector in a space, vector space. The orthogonal projection of y on u can be written as y dot u by u dot u into u. This is orthogonal projection is denoted by y cap. Y cap is the orthogonal projection of y onto the vector u. This is the formula. Right? You know how to find the dot product or inner product. This is also inner product. Now one example I am taking. Let y is equal to 7, 6, right? And u is equal to 4, 2. Right? Find the orthogonal projection. Orthogonal projection. Orthogonal projection means this is the formula. Y cap is equal to y dot u by u dot u into u. Right? Now, see, first of all, I am finding u dot u transpose u, which is nothing but 4 2 into 4 2, which is nothing but 4 into 4 plus 2 into 2. 4 4s are 16 plus 2 2s are 4. This is equal to 20. Therefore, u dot u is equal to 20. Next one is y dot u have to calculate. Y transpose u. What is y here given as 7 6. U is 4 2 is equal to 7 into 4 plus 6 into 2, which is 28 plus 12. 40, no? Therefore y dot u is equal to 40. The orthogonal projection y cap is equal to, now what is the formula? Y dot u by u dot u into u, which is equal to y dot u is 40 by u dot u is 20 into u is what? 4 2. Right? Now here we will get it 2, no? 4 2. Simplify this one. 4 into 2, 2 into 2. This is equal to 8, 4. Therefore, the orthogonal projection of y onto the vector u is equal to 8, 4. Right? This is an important concept. Find the orthogonal projection. And there is one important another thing when is there, this y is equal to y cap plus y minus y cap, right? And this is called z. Z is a vector, right? Any this y, the given vector y can be written as y cap plus z. The given vector y is nothing but the orthogonal complement of y onto a vector u plus another vector z compo, some vector in r power n. What is z means? Z is nothing but y minus y cap, right? What is the definition of orthogonal projection? Orthogonal projection is defined by the dot product of y and u, right? Now the orthogonal projection of y onto a vector u is denoted by y cap, and which is defined as y dot u by u dot u into u. This is the definition, very very important definition, orthogonal projection. Next one is orthonormal set. Orthonormal set. This is not there in our syllabus. Still one చెప్పుకుందాం. Very easy one. You know orthogonal set. Orthogonal set means a set is said to be orthogonal if each pair of vectors are orthogonal to each other. Right? Suppose S is equal to u1, u2, u3. There are three vectors are there. This set is said to be orthogonal if each pair of vector, that means u1 dot u2 is equal to 0, u2 dot u3 is equal to 0, u3 dot u1 is equal to 0. If the dot product is equal to 0, then these two are said to be orthogonal vectors. If each pair of vectors are orthogonal, then the set is said to be a orthogonal set, right? Now what is the definition of orthonormal set? Orthonormal set means a set is said to be orthonormal set if it is orthogonal and also all the vectors in S are unit vectors. What do you mean by unit vectors? A vector is said to be unit vector if its length is equal to 1. That means norm u1 is equal to 1, norm u2 is equal to 1, norm u3 is equal to 1. Right? Now, what is the definition of orthonormal set? A set is said to be orthonormal if it is orthogonal set and also the vectors are unit vectors. You can combine these 2 points, right? Now we can say that a set is said to be an orthonormal set if it is orthogonal unit vectors. For example, S is equal to, I am giving you V1 comma V2 comma V3. This is a homework for you, where V1 is equal to 3 by root 11, 1 by root 11, 1 by root 11, right? V2 is equal to minus 1 by root 6, 2 by root 6 and 1 by root 6. Now V3 is equal to minus 1 by root 66, minus 4 by root 66 and 7 by root 66. Now show that this is orthonormal set. Orthonormal set means what we have to show? First of all, it is an orthogonal set. That means v1 dot v2 you have to show that 0. v2 dot v3 is also 0. v3 and v1 is equal to 0. If their dot product is equal to 0, then it is an orthogonal set. And each vector, if the length of each vector is equal to 1, then the set is said to be orthonormal set. Try to solve this one. Okay.